NEC Article 285 addresses lightning protection systems. Section 285.16 specifically covers the overcurrent protection of branch circuits that supply lightning arresters. Subsection A focuses on the protection of branch circuits leading to lightning arresters. It mandates that each branch circuit supplying these arresters must be protected by an overcurrent device. Critically, this overcurrent device must be situated on the line side of the lightning arrestor itself. This placement ensures that any overcurrent condition originating in the branch circuit is detected and interrupted before it can reach and potentially damage the lightning arrestor. Now let's look at subsection B, which deals with the maximum rating of the overcurrent protective device. This section stipulates that the maximum overcurrent protection rating for conductors supplying lightning arresters must adhere to the guidelines outlined in Table 285.16. Table 285.16 provides a clear and concise framework for determining the appropriate overcurrent protection rating based on the nominal voltage of the circuit in question. For circuits with a nominal voltage ranging from 0 to 150 volts, the maximum allowable overcurrent protection rating is 15 amps. This means that the circuit breaker or fuse protecting the branch circuit should not exceed 15 amps. For circuits operating at a higher nominal voltage, specifically those ranging from 151 to 600 volts, the maximum permissible overcurrent protection rating is increased to 30 amps. Again, this limits the size of the overcurrent device protecting the circuit to a maximum of 30 amps. The reason for these voltage-dependent ratings lies in the inherent characteristics of electrical circuits and lightning arresters. Lower voltage circuits typically handle smaller currents, thus requiring lower overcurrent protection thresholds. Conversely, higher voltage circuits are capable of carrying larger currents, necessitating higher overcurrent protection ratings. It is important to note that adhering to these maximum overcurrent protection ratings is crucial for ensuring the safe and effective operation of lightning protection systems. Using an overcurrent device with a rating that exceeds the specified maximum can lead to inadequate protection, potentially allowing excessive current to flow through the lightning arrestor during a surge event. This could result in damage to the arrestor, the connected equipment, or even create a fire hazard. Conversely, using an overcurrent device with a rating that is too low can cause nuisance tripping, interrupting the circuit unnecessarily and disrupting the operation of the protected equipment. Therefore, careful consideration must be given to the nominal voltage of the circuit when selecting the appropriate overcurrent protection device for a branch circuit supplying a lightning arrestor. Consulting Table 285.16 in the NEC is essential for ensuring compliance with code requirements and maintaining the safety and reliability of the electrical system. In summary, NEC Article 285 provides comprehensive guidelines for lightning protection systems, with Section 285.16 specifically addressing the overcurrent protection of branch circuits supplying lightning arresters. By adhering to the requirements outlined in this section, including the maximum overcurrent protection ratings specified in Table 285.16, electrical professionals can ensure the safe and effective operation of these critical protective systems. When installing or maintaining lightning protection systems, always refer to the latest edition of the NEC and consult with qualified electrical inspectors to ensure compliance with all applicable codes and regulations. Proper overcurrent protection is just one element of a comprehensive lightning protection strategy, but it is a vital one for safeguarding people, property, and equipment from the hazards associated with lightning strikes. The role of overcurrent protection devices, such as circuit breakers and fuses, is to interrupt the flow of electrical current when it exceeds a predetermined safe level. This prevents overheating of conductors, insulation breakdown, and potential fire hazards. In the context of lightning protection, overcurrent devices protect the branch circuits supplying lightning arresters from excessive current flow that could occur during a lightning surge event. The selection of the appropriate overcurrent protection device involves considering several factors, including the ampacity of the conductors in the branch circuit, the type of load being served, and the specific requirements of the lightning arrestor being used. The NEC provides guidance on selecting the appropriate overcurrent protection device for various applications, including lightning protection systems. In addition to the maximum overcurrent protection rating specified in Table 285.16, it is important to consider the interrupting rating of the overcurrent device. The interrupting rating is the maximum amount of fault current that the device can safely interrupt without failing. For lightning protection applications, it is crucial to select an overcurrent device with an adequate interrupting rating to handle the potentially high fault currents associated with lightning surges. The location of the overcurrent device is also critical. As stated in Section 285.16a, the overcurrent device must be located on the line side of the lightning arrestor. This ensures that the arrestor is protected from overcurrents originating in the branch circuit. In addition to overcurrent protection, lightning arrestors themselves play a crucial role in protecting electrical systems from lightning surges. Lightning arrestors are designed to divert high-voltage surges to ground, preventing them from damaging sensitive electronic equipment. They are typically installed at the service entrance of a building or at other critical locations in the electrical system. When a lightning surge occurs, the arrestor provides a low-impedance path to ground, diverting the surge current away from the protected equipment. The arrestor then automatically resets, ready to protect against subsequent surges. Proper grounding is essential for the effective operation of lightning arrestors. The grounding system provides a low impedance path for the surge current to flow to ground, minimizing the voltage rise on the electrical system. The NEC provides detailed requirements for grounding electrical systems, including lightning protection systems. These requirements cover the size and type of grounding conductors, the methods of connecting to ground electrodes, and the overall design of the grounding system. Regular inspection and maintenance of lightning protection systems are crucial for ensuring their continued effectiveness. This includes inspecting the lightning arrestors for damage or deterioration, checking the grounding connections for corrosion, and verifying the integrity of the overcurrent protection devices. Any deficiencies should be promptly corrected to maintain the safety and reliability of the system. Furthermore, advancements in lightning protection technology continue to emerge, offering improved performance and reliability. These advancements include surge protective devices with enhanced clamping characteristics, improved grounding techniques, and sophisticated monitoring systems that provide real-time information on the status of the lightning protection system. Staying abreast of these technological advancements is essential for electrical professionals involved in the design, installation, and maintenance of lightning protection systems. In conclusion, NEC Article 285 provides comprehensive guidance on lightning protection systems, including the overcurrent protection of branch circuits supplying lightning arrestors. By adhering to the requirements outlined in this article and staying informed about the latest technological advancements, electrical professionals can ensure the safe and effective protection of people, property, and equipment from the hazards associated with lightning strikes. It is important to emphasize that lightning protection is a specialized field, and it is recommended to consult with qualified lightning protection professionals for complex installations or when dealing with higher risk applications. These professionals have the knowledge and experience to design and install lightning protection systems that meet the specific needs of the application and comply with all applicable codes and regulations. In addition to the technical aspects of lightning protection, it is also important to educate the public about the dangers of lightning and the importance of taking appropriate safety precautions. This includes staying indoors during thunderstorms, avoiding contact with electrical appliances and plumbing fixtures, and seeking shelter in a safe location if caught outdoors. By raising awareness about lightning safety, we can help to reduce the risk of lightning-related injuries and fatalities. Finally, it is worth noting that the Canadian Electrical Code also addresses lightning protection, although the specific requirements may differ from those in the NEC. Electrical professionals working in Canada should consult the CEC for guidance on lightning protection systems in that country. The CEC provides detailed requirements for grounding, bonding, and surge protection, as well as specific requirements for lightning protection systems. By understanding and complying with the applicable electrical codes, whether it be the NEC or the CEC, electrical professionals can ensure the safe and effective protection of electrical systems from the hazards of lightning. The coordination between lightning arresters and overcurrent protection devices is crucial for the overall effectiveness of a lightning protection system. The overcurrent device is intended to protect the branch circuit wiring from overloads and short circuits, while the lightning arrestor is intended to divert high voltage surges to ground. The overcurrent device should be sized and selected to allow the lightning arrestor to function properly without tripping unnecessarily. This requires careful consideration of the arrestor's surge current rating and the overcurrent device's interrupting rating. In some cases, it may be necessary to use a special type of overcurrent device, such as a surge-rated circuit breaker, to provide adequate protection for both the branch circuit wiring and the lightning arrestor. Surge-rated circuit breakers are designed to withstand the high surge currents associated with lightning strikes without tripping prematurely. They typically have a higher interrupting rating and a faster response time than standard circuit breakers. When selecting a surge-rated circuit breaker, it is important to choose one that is specifically designed for use in lightning protection applications. These breakers are typically marked with a surge protection or lightning protection designation. In addition to surge-rated circuit breakers, there are also surge protective devices that can be installed in parallel with the branch circuit wiring to provide additional protection against lightning surges. These devices, known as surge suppressors or transient voltage surge suppressors, are designed to clamp the voltage to a safe level, preventing damage to sensitive electronic equipment. Surge suppressors are available in a variety of voltage ratings and surge current capacities, so it is important to select one that is appropriate for the application. They can be installed at the service entrance, at distribution panels, or at individual equipment locations. When installing surge suppressors, it is important to follow the manufacturer's instructions carefully. This includes ensuring that the device is properly grounded and that it is connected to the branch circuit wiring in accordance with the electrical code. Proper installation is essential for the effective operation of surge suppressors. Furthermore, the grounding system plays a critical role in lightning protection. A well-designed grounding system provides a low impedance path for surge currents to flow to ground, minimizing the voltage rise in the electrical system. The grounding system should be designed in accordance with the requirements of the electrical code, and it should be regularly inspected and maintained to ensure its effectiveness. The grounding electrode system typically consists of one or more ground rods, ground plates, or buried ground conductors. The size and type of grounding electrode should be selected based on the soil conditions and the size of the electrical system. The grounding conductors should be sized in accordance with the electrical code, and they should be securely connected to the grounding electrodes and to the electrical equipment. In addition to the grounding electrode system, it is also important to bond all metallic parts of the electrical system together. This includes bonding the service entrance equipment, the distribution panels, the metal conduits, and the metal enclosures of electrical equipment. Bonding helps to equalize the voltage potential between these metallic parts, reducing the risk of electric shock during a lightning surge. The bonding conductors should be sized in accordance with the electrical code, and they should be securely connected to the metallic parts of the electrical system. Regular inspection and maintenance of the grounding and bonding system are essential for ensuring its continued effectiveness. This includes checking the grounding connections for corrosion, verifying the integrity of the grounding electrodes, and testing the resistance of the grounding system. Any deficiencies should be promptly corrected to maintain the safety and reliability of the electrical system. Lightning protection is a complex and multifaceted topic, and it is important to consult with qualified electrical professionals for the design, installation, and maintenance of lightning protection systems. These professionals have the knowledge and experience to assess the specific needs of the application and to design a lightning protection system that meets all applicable codes and regulations. Remember, lightning protection is not a one-size-fits-all solution. The specific requirements will vary depending on the location, the type of building, the type of equipment being protected, and the level of risk. A thorough assessment of these factors is essential for designing an effective lightning protection system. And finally, it is always a good idea to review your insurance coverage to ensure that you have adequate protection against lightning damage. Your insurance policy may have specific requirements for lightning protection, and it is important to comply with these requirements to ensure that your coverage remains in effect.